Here's a quick lesson on fractions and decimals and how they are related to each other and how we can change things back and forth. So we know that this is what a fraction looks like right here, a over b. And then we have over here a decimal. Okay? Now, let's deal with fractions first. A fraction is made up of a numerator and a denominator. The numerator is on top, the denominator is on the bottom. This fraction bar is another word for a division sign. So this is a divided by b, the numerator divided by the denominator. We can kind of look at this as shorthand or like text talk. Now, what we want to do is, it's really hard to divide fractions this way, so we kind of equate this division sign with the long division sign, which looks like this. So we should be thinking about that fraction is actually a long division problem. I think what fools most people is what goes where. We want to know that the numerator goes inside the long division sign and the denominator goes outside the long division sign. We do that, and that way we're set up to start dividing and solving for our fractions and simplifying them into decimals. Now let's talk about the basics of decimals. The basic of decimals is this. We got to look at place value. Place value is where everything is at. Okay, you'll see here in this first one, I have a number in front of the decimal point. Well, that number is going to represent our whole number that we're going to use when we change to a fraction. So if I just wanted to show 1 as a whole number, I would just say 1. Now, when I'm looking over here at this 0.1, the way we read that is in the tenths place. So that would be read as 1/10. If I wanted to put these together, 1.1, we'd read this as 1 and 1/10. 1 and 1/10. We look at the next one here, that would be tenths. This would be hundredths. If I was trying to write the number 1.01, we would read that as 1 and 100th. It would look like that. This last one here is the thousandth place. And you will notice that everything to the right of the decimal ends in THS. A little something there. And if I wanted to write 1.001, we would read that as 1 and 1,000th. And that's how it would translate from a decimal to a fraction. All right, now let's go back and take a look at this fraction, 1/4, and talk about exactly where things go and how to remind ourselves about dividing by and using decimals with long division. So we look and we say 4 cannot go into 1. So we're going to put a 0 up here. What that does is, if we're going to start to add things to it, we've got to put a decimal there. That means that we're going to go past where this number normally would have been, because it was a 1. So now we're going to look at 4 going into 10. 4 goes into 10 2 times. So we're going to write down an 8. And we subtract that. 10 minus 8 would give us 2. Now again, 4 cannot go into 2, so we're going to add another 0, bring our 0 down, and we find that 4 can go into 20 5 times. And 4 times 5 is 20. And now it ends out. So we can say that 4, 1/4, can be changed into the decimal of 0.25. Now another way to think about this is this. We can think about this in terms of taking that fraction and changing it. So if I wanted to take 1/4 and I wanted to change it in terms of a decimal, I know that my place value is tenths, hundredths, thousands. Now 4 can't go into tenths, so I can't find a number that's going to multiply 4 by to get 10 there. But can 4 go into 100? 4 times what will give us 100? We know that that's going to be 25. 4 times 25 is 100. We also know that if we multiply any number by 1, it doesn't change it. That is true for fractions. So 4 times 25 is 100. 1 times 25 is 25. Again, we read this as 25 hundredths. We can then translate that fraction straight into a decimal at that point. So there's another way to change fractions into decimals, by finding that place value. Okay, now when we have decimals and we want to change them into fractions, we're going to follow the 3 R's, as I call them: read, write, and reduce. So the way we read this is we read it as 25 hundredths. So we're going to write exactly that, 25 hundredths. We need to reduce that, so we're going to think of the largest number that goes into both 25 and 100, and go by 5, because I know some people may not think of the largest number. 25 divided by 5 is 5, and that becomes 20. And we can see that it'll go again. We can divide by 5 again, and we end up with 1/4. We could have divided straight up by 25 the first time if we thought of a number that large. So this is how we go about changing a decimal into a fraction. We're going to read it, we're going to write it, we're going to reduce it. Okay, let's practice a couple problems very quickly. Let's take a look at 3/5. Again, we're going to take the numerator, put it inside the long division sign, put the 5, the denominator, outside the long division sign. 5 cannot go into 3, so we're going to put a 0. Add a decimal point, because we're going to add some zeros to this. 5 goes into 30 6 times, and 30 take away 30 is 0. So our answer then, in changing this fraction to a decimal, is 0.6. Again, I could have done it the other way as well. I could have sat there and said, is there a number I can multiply 5 by to get to the 10th place? And that would have been 2. I would have multiplied it by 1, find out it's 6/10. We know that 6/10 can translate and look exactly like this as a decimal. Let's go the other way. Let's take a decimal and change it into a fraction. So we're going to read it, write it, and reduce it. When I read this, this is read as 2 35 hundredths. So I write it down, and then I've got to reduce it. I'm only concerned with the 35 hundredths. I know that 5 will go into both of those numbers. And again, dividing something by 1 doesn't change it. 35 divided by 5 is 7. 100 divided by 5 is 20. So we have 2 7/20. That is what 2.35 or 2 35 hundredths changes to as a fraction. Now let's take a moment and talk about repeaters. Okay, repeaters use a bar. So we want to think about how we're going to change this 0.3 with a bar on it. Now, normally, if there was no bar, we would say that this was 3/10. We know that this with the repeater on it is more than 3/10. It's 3 going on forever. So if we think about it in terms of a pizza, if I cut the pizza into fourths, we can see 4 equal pieces. If I cut it again, now I have 8 pieces. So as the denominator increases, the pieces get smaller and smaller. Well, here, I'm not going to change this to be 1 up because it's so close. This can't be 11, because if I change this to 3/11, means that it's going to be smaller than this. We want something a little larger. So really, this is going to translate into 3/9. Now, there's a shortcut into thinking about this as well. You see this little bar? This is another thing that some people think about. We know the numerator is what is repeating. The denominator is going to be 1 less than the place value. So since this place value is the tenths, it's 10 take away 1, and we can think of that bar as a 1. So 10 take away 1 is 9, and we get 3/9. We can divide 3/9 both top and bottom by 3, and we find out that that becomes 1/3. We can use that rule again here, showing 45 hundredths repeating. So this is going to be 45 divided by 100 take away 1 is 99. So 45 divided by 99. We think about the largest number that divides into both 45 and 99, and that's 9. And then we can simplify that down to 5/11. I think what's interesting about repeaters is that you will get numbers in the denominator that you can multiply by. They'll be prime odd numbers that you can multiply to get those repeating areas: 9, 99, 999. These numbers that will show up in the denominator of a repeating decimal. Okay, using that premise, you see 0.2 with a bar over it. It is not 2/10, it is 2/9. We'll take a look at one more. Changing 6/11 to a decimal, going back the other direction. Again, you could take the numerator 6, put it inside the long division sign, the 11 outside the long division sign. 11 cannot go into 6, so we're going to put a 0, put a decimal point and add a 0 onto 60. 11 goes into 60 5 times, so we'll subtract 55. 60 minus 55 is 5. Bring down another 0. 11 goes into 55 4 times. That's 44. And again, that's going to give us 6. We can see that a pattern is going to start to develop. 60, again 5. That's going to be 55. Again 4. We can see this pattern. So we know that it's going to be 5 4 5 4 5 4. We can then at that point change it to read 0.54 with a bar over it. Now again, another way to do this is to take a look at that 6 11s and think, is there, because of this being prime, we know that that's probably going to be an odd repeater. So we know 11 can go into 99. We know 11 can go into 99 9 times. This will get us 54 over 99. Again, we would change that 54 over 99 as a repeater. That would be a bar over the top like that. So that's the end of this notes on that concept of fractions and decimals.